Hey everybody, what is up? We're going to continue our discussion of evaluating limits. Now in the previous video we did a direct substitution in which we could take the factor that we're approaching to, or the value that we're approaching to, like x equals 4, and just do a direct substitution for x, and then we can find out what that limit approaches. But in some cases, direct substitution will not work. In some cases, we're actually going to have a case where we're going to get a 0 in the denominator, and as we all know, that is a no-no. So we can't do that. We can't have 0 in the denominator. Like in this example here, like if we substituted 4 in for x, we'll get 4 minus 4, which will equal 0. So we can't have that. So next step is actually factoring the limit. And in this case, what we want to do is actually cancel out an expression. And then that way, when we do plug in our value, that we do get an actual value that the limit is approaching. So in this example, we're going to have the limit as x approaches 4 of the function x squared minus 4 over x minus 4. And as I said, if we plugged in 4 here, we'll get 0 in denominator, which we can't do. Slap your hand if you do. So what we're going to do is actually factor this numerator here. So what we will get is, in the numerator, if we factor x squared minus 4, that factored out is going to equal x minus 4, x plus 4. And so we will substitute this expression for x squared minus 4. So what we'll now have is the limit as x approaches 4 for x minus 4, x plus 4 over x minus 4. And as we can see, we have the expression x minus 4 over x minus 4. That cancel out. And then that leaves us with the limit as x approaches 4 of x plus 4. And if we now do a direct substitution of 4 for x, we'll get 4 plus 4, and then that will equal 8. So this limit, as we can see, if we did our last method, which is usually your first line of attack when evaluating limits, direct substitution, but in this case, if we do that, we'll get 0 in denominator, which can't happen. So next step is we'll try factoring out the numerator or do a conjugate or some sort to see if we get some things that cancel out that will allow us to properly evaluate that limit. And in this case, it does. We get x equals, well, if we substitute x for 4, we'll get the limit equals 8. So let's go ahead and try another example. Here's another example with a quadratic in the numerator. So we have the limit as x approaches 4 over x squared minus 7x plus 12 over x minus 4. So again, doing a direct substitution of 4 will get us a 0 in the denominator. That's a no-no, so we can go ahead and try and factor this quadratic. So a slight refresher on factoring quadratics. If it's in this form here, the easiest method that always stuck with me is to two numbers that add to make this middle number and also multiply to make this number here. And the two numbers, if we factor this quadratic out, we'll see that x minus 3 times x minus 4, if we FOIL this out, will give us this quadratic right back here on the numerator. So the limit as x approaches 4 of x minus 3 times x minus 4 over x minus 4, and we see we got an x minus 4 here. We can cross out, and so that will give us the limit as x approaches 4 of x minus 3. And if we go ahead and substitute our 4 for the x here, we will get 4 minus 3, and our limit for this function approaches 1. So as you can see, evaluating limits aren't that bad as long as you remember the methods that is involved with factoring or direct substitution, and as I'll go over soon, conjugates. So these are 2 basic examples, but you can pretty much use this method for any time you need to factor any type of function. All right, I'll go ahead into the next video. Hope you guys have a great day.